Hello, I'm Nick Mikhaylovskiy, and today we are presenting NTR and Tomsk State University submission to SIGTYP shared task on robust low-resource language identification. For this shared task, we have taken a production quality language identification system, basically cut out and simplified a part of a production automated speech recognition pipeline. The language identification system is based on a well-known and popular QuartzNet architecture from NVIDIA. The architecture accepts MFSC or MFCC coefficients and processes in an architecture that consists of identical blocks that in turn consist of identical subblocks. Each subblock applies a 1D convolution, a batch norm, ReLU, and dropout. Blocks and subblocks are connected with residual connections. In a production environment, the language identification system is trained on a proprietary dataset, which consists of over 30,000 hours for 8 languages, and is very fast and accurate, 97% plus in domain. To show the efficiency of the architecture, we have trained the system on VoxForge dataset. We selected 1,500 samples for each of 6 languages, similar to Sartak with colleagues, and split the data 4:1 to train and test. Models were trained until they reached a plateau on validation set. Training was done using the stochastic gradient descent optimizer with initial learning rate of 5,000 and cosine leading decay to 1/10,000. For such a setting, while the system doesn't achieve the state of the art, it shows pretty decent results, namely 92.5% accuracy and 95, while the state of the art for this setting is achieved by cited work by Sartak and others. They used a more aggressive augmentation mix-up, but also this difference may be a result of difference in datasets because both datasets were selected from the single large source stochastically and can be significantly different datasets. This language identification system trained this way shows very meaningful confusions, namely the confusion matrix on VoxForge dataset is very meaningful. For example, if you look at rows which show the actual language, German is most confused with English, which is a related German language. And English is vice versa, most confused with German. Spanish is most confused with Italian, which is another Romance language. French is most confused with English and Italian. Italian is another Romance language, and English had very strong historic ties with French. Basically, English have borrowed during the Middle Age a lot of lexis from French. Italian is most confused with Spanish, which is another Romance language, and that's again very meaningful from linguistic perspective. And Russian, which is the only language in this data set that is Slavic and is single in this group, is most confused with Spanish and French. It's actually hard to explain the Spanish confusion, but confusing Russian with French can be again explained by close ties Russian and French languages had in 18th and 19th century, when Russian have borrowed a lot of lexis from French. For the SIGTYP shared task, the dataset The trained dataset consists of one-speaker recordings from CMU Wilderness dataset, basically Bible read by a single speaker. Test consisted of varied recordings from varied domains. Common Voice project, which is read speech typically recorded using built-in laptop microphones, radio news data, crowdsourced recording using portable electronics, cleanly recorded microphone data, and a collection of recorded from varied sources, all for different languages. This list of languages includes 16 languages from 8 families and isolates, like Basque. With this out-of-domain test data, the resulting confusion matrix mostly describes non-linguistic, domain-specific data. As the data were supplied in MFCC form, we didn't listen to the samples, being short of time to use the recorder. But we hypothesize that the two languages to which the recordings were mostly confused, Kabyle and Telugu, actually represent the speaker gender. This leaves the question of robust language identification essentially unanswered, but from our perspective, so do the submissions that augment the data by using the validation dataset, which is normally a bad practice in machine learning. Still, robust language identification is an important direction for the future research for many groups, including our own group. Thank you for the attention.